Gas Safety Technologies, currently deployed in the Northeast and Mid-Atlantic states. I know that we have a few registrants from outside that region, so welcome one and all. We're very happy to have you on today. I'm Matt McCaffrey from our Regulatory Affairs team, and I will be emceeing today's call. Before we get into the subject matter, I wanted to cover a few housekeeping items. So if we could advance to that slide. We're recording this, and we will be sending out an email post-event to all registrants and invitees with a link to the recording. The email will include my contact information. If you have any follow-up questions or comments, please feel free to reach out. To cut down on background noise and to make sure we get to all our content today, everyone is muted except for the presenters, but you can ask questions. If you look at the bottom right of your screen, you should see a Q&A field. Please submit any questions through that, and I will moderate a Q&A session immediately following our two presenters today. For any questions we don't get to follow up after the webinar. So we wanted to host today's webinar to highlight some of the innovations currently being deployed by our natural gas utilities, our natural gas utility clients. And let's face it, natural gas distribution technology isn't always in the limelight, but it certainly deserves our attention. Hopefully through these presentations today, we'll be able to show you how these technologies can proactively increase safety for utility customers. At a high level, these technologies help utilities increase the accuracy and responsiveness across their systems, which ultimately translates into safety dividends and reduced operational costs for their customers. Today, we'll cover two topics: the intelligent gas meter, the Intelis meter, and our methane sensing and safety technologies, and how they both leverage autonomous technologies at the premise level to dramatically reduce reaction time for potentially critical events. Our first speaker today will be Janet Pant, our Senior Product Line Manager, who will talk about the Intelis meter. Then we'll turn it over to Brian Fute, our Gas Marketing Strategist, who will talk about methane sensing. So with that, I will turn it over to Janet. Janet, thank you. Take it away.
Thank you, Matthew. I appreciate everyone's time this morning. I'm very excited to be talking to you about our revolutionary Intelis gas meter. I work out of our factory in Minnesota. I've been with Itron 23 years, and all of our products on the gas side are the Intelis gas meter, all of our gas modules, they're manufactured in Waseca. So I have the advantage of having a foot in the factory, which is always helpful. So let's get started. Intelis was not developed in a vacuum. As a matter of fact, at the American Gas Association 2017 meeting, we actually had a private room demo session where we showed the concept of the Intelis meter to the gas utilities. There were a total of 50 people in attendance, representing a total of 16 different gas utilities across the United States. And what we did is we showed them a mock-up version, an actual demonstration, a live demo, where we were actually blowing air through the meter. And what we did is got the flow rate up to a certain amount, and we were able to show that the valve inside the meter was automatically able to shut the flow through the meter off. And the utilities, this demonstration, they really understood what our value proposition was. And they basically were finishing our sentences. They said, oh, it's like an excess flow valve, but inside the meter. So for those of you familiar with the excess flow valve in the bottom right corner, those are used on distribution lines to provide a level of safety before the meter. So if someone's doing construction, you know, you hear about these incidences all the time where people don't call before they dig, or they call, but they still have a, you know, some construction equipment that is digging up the dirt, and they mistakenly dig up the gas line. And that excess flow valve is actually acting as a safety device so that the flow of gas is shut off. Well, that excess flow valve that's in the utilities distribution lines leading up to the home, it doesn't help you if there's a break in the fuel line inside the house. It only helps if there's a break in the fuel line on the distribution line. So we wanted to take the concept of the excess flow valve and move it downstream. In other words, we actually put the shutoff valve inside of the meter. And we asked a very simple question at the end of the demonstration. What did you think? You know, was this interesting or not interested, or is this a game changer? And 71% of those people that we surveyed gave this a rating as a game changer. And for folks that have spent their careers in the natural gas industry, you don't often hear the word game changer in the natural gas industry. At least that's been our experience. So we felt like, okay, we're on to something here. You know, bringing a value proposition around safety to the market is probably a very good thing for us to do. So that's how Intelis got started in 2017. We go to the next slide. Our official release of the Intelis gas meter to the marketplace was actually April 30th, 2019. It just so happens that it was an exhibition year for American Gas Association. So we literally opened our doors to the showroom, and there is Intelis, and it had been blessed to be released to the marketplace. Talk about just in time. We actually got our approval the day the doors opened, and that's no coincidence. We were pushing really hard to make sure that that happened. One of the things that I think is a testament to the Intelis gas meter is the fact that you can see in the little logo there in the top right corner. It was actually the winner of the 2019 IoT Internet of Things Breakthrough Award as being the Public Safety Solution of the Year. And the mission of the IoT Breakthrough Award is to recognize innovators and leaders and visionaries from around the globe. So it wasn't just a US-based award. And, you know, recognizing them in a range of IoT categories, including smart metering. There were actually a total of 3,500 nominations that went into this, and Intelis was picked as the winner. So we were pretty excited about that. I'll talk more about why you might think we were worthy of that award as we get into it. But for those of you who may not be familiar with Itron, we have a long history in the natural gas industry. As a matter of fact, our very first gas modules came out of Waseca, Minnesota in 1986. This is the banner that we showed in the background at AGA in 2019. At the time, we had shipped 70 million gas modules. Today, I'm proud of the fact that we've now shipped more than 75 million gas modules across North America. So we have quite the history on the gas side. We also do everything, you know, from the standpoint of the metering, the head-end system, the support for services. And this is a market that Itron actually invented, was gas AMR, now gas AMI. You can see in the graphic there at the bottom right, looking at the Intelis gas meter in an installation, a much more compact installation. So why don't we get into some of the benefits if we go to the next slide. So the nice thing about Intelis is that we're actually bringing 3 products together into one product. So it's a meter. I don't know if you can see my cursor here. This is what we call the ultrasonic measuring unit. And we're actually purchasing this from a third-party vendor in Japan. They've actually been using ultrasonic measuring units, solid state meters, if you will, in Japan for more than 2 decades. The vendor that we're working with has actually shipped 6.8 million ultrasonic sensors to the marketplace over about 20 years in time. Of those 6.8 million ultrasonic sensors, 4.6 million of them are what we call an ultrasonic measuring unit, or UMU as an acronym. So this gray device that you see, towards the middle left of the meter. So they've actually shipped 4 million of these ultrasonic measuring units to the field. The only difference between the UMUs that they have shipped and what Itron is purchasing is we have a more accurate temperature sensor that we have asked for in our meter. And it leads us to a much more highly accurate meter than what is seen overseas. So North America tends to have tighter specs, if you will, and tighter requirements. So the only difference between the 4.6 million that this vendor has shipped and what Itron is purchasing from them is a more accurate temperature sensor on the UMUs that Itron is purchasing. So, you know, we wanted to take proven components and use and bring them into our meter. Along that same thought process, if you can see my my mouse here, this is the shutoff valve. It's a safety shutoff device. It's referred to as an actuated swing valve. If you want to, in the open position, it would be at a 45-degree angle. We do a 45-degree angle, so we get less turbulence of the gas flow through the meter. It's actually better at a 45-degree than it is at a 90-degree when it's wide open. So this actuated swing valve or safety shutoff that we're using inside this meter, again, we actually took a component that we're using at Itron for prepayment meters. Now, those prepayment meters are used outside of the United States, but we have quite the history with prepayment meters, and we've actually been doing shutoff devices in prepayment meters since 2004 at Itron. And we've actually 3.2 million prepayment meters. Granted, they were diaphragm prepayment meters. They were not ultrasonic prepayment meters, but we have shipped 3.2 million diaphragm meters with safety shutoff valves or with shutoff valves for prepayment purposes. And this exact version that is in the Intellis gas meter for this safety valve is actually the same as what we've been shipping to the marketplace in 2013. So we've actually shipped 1 million of this exact same version shutoff device, even though it's been in a different type of a meter, but the device is the same. So again, we wanted to minimize risk with new product introduction, taking proven components. The third piece of the solution is, of course, the radio device, the RF or radio frequency communications. And I'm not showing it in this picture here, but it bolts on the front of the meter. And this is where Itron has now shipped 75 million gas modules over the course of, you know, our history in gas. So since 1986, we have actually shipped 75 million gas communication modules. And the RF communications device that gets bolted onto this meter, it's basically our latest technology that we're using. So there's a lot more bells and whistles in it than some of our earlier technologies. This whole meter is powered by 4 A-cell batteries. They're in the index area. And it's giving us a full 20-year life. So this is a product where you don't do any kind of maintenance on it or anything with respect to the meter or the radio. You put it in service after 20 years. You're going to want to remove it from service and replace it with then the latest and greatest. Okay, if we continue. So what are these great benefits? Why do we think we might have won this award? Well, it has to do with distributed intelligence. And as I said, I've been with Itron a long time now. I used to get jealous on the electric side. There was all this talk of all these cool things that, you know, they do on the electric side, smart metering and distribution intelligence, where it's done at the meter level. And we really didn't have much to say on the gas side of things, and Intellis has really changed it for us. What we have is a high flow alarm, and this allows the meter. So we're doing at the factory, we actually program in a flow rate of 500 cubic feet an hour. And if the meter sees 500 cubic feet an hour, it automatically shuts off within 10 to 15 seconds. We also allow the utility to define a lower threshold if they want a lower threshold. You know, they might be using it in an application where they might want that safety shutoff valve to trip sooner at a lower flow rate. So we've built in some flexibility. But the nice thing about this high flow limit is that you don't even need a network. You don't need mobile data collection. You don't need handheld. Basically, the meter is programmed before it ships our factory. And if it sees the flow rate that's defined, it's going to shut itself off automatically and then send a high flow alarm. So that is what we consider distributed intelligence. And as I said, it's going to benefit both mobile and network users. And it's basically acting like an excess flow valve. So if someone opens a fuel line in the home or steals something, some appliance from the home, and there's an open fuel line, or intentionally thinks they're going to, you know, blow up a house to try and collect insurance money, this meter is smart enough to know that it's an unsafe situation as defined by the high flow limit, and it's going to shut itself off automatically. Since we actually have a temperature sensor in the radio, there's a temperature sensor in the index area because we want to keep track of the time accuracy. So we had to have obviously we have a temperature sensor inside the meter. That's what's giving us our nice accurate measurement. But we also had a temperature sensor in the radio. So we decided to make use of that temperature sensor, and the utility is able to set a high temperature limit whereby the meter will shut itself off if that threshold gets reached. Now, we've realized that the radio portion of the Intellis meter is made out of plastic. By the way, the meter itself is traditional die-cast aluminum, just like the gas meters that are used in North America today. But our whole value proposition with Intellis is built around safety. So we figured if we can shut the valve inside the meter automatically based on high temperature, you know, maybe it gives the utility a couple more minutes or many more minutes of response time. And sometimes 1 minute can make the difference between a good outcome and a bad outcome. So we have also built in, if the utility chooses for the meter to shut off on high temperature, that's also done right at the meter level. You don't need a network to monitor it. You don't need to be sending commands through a mobile or handheld device. The meter is smart enough to just take care of the situation. And the last thing is, you know, what everyone loves is if someone calls the utility and reports smelling gas, it is very, very convenient to be able to send a command over the network to shut the valve inside the meter. And that is obviously where having a network is much more advantageous. But there's even benefits if you're a mobile handheld customer. And basically, you know, right now when utilities go out to investigate, they're having to walk right up to typically the shutoff valve is pretty close to the house. So they're having to walk right up to an area that might be dangerous in order to stop the flow of gas. And at least even if they're a mobile or handheld customer, they're able to send that RF command from a distance and be able to shut the valve inside the meter. So those are a couple of the key safety benefits. Moving on to the next slide, I just want to emphasize the fact, though, on the next slide, that we are very much positioning this product as a safety shutoff valve. It is not intended for permanent disconnect of a service. This is all about safety. We want to minimize that flow rate. There is a little bit of gas that is still going to go downstream of the meter once the valve is closed. That amount of gas is the equivalent of 1 liter an hour. I had mentioned that we're using a valve that we use outside of North America for prepayment meters. So the allowable rate of gas flowing was in fact 1 liter an hour. That's the equivalent of 0.035 cubic feet an hour. So just to get, how much gas is that in our heads? It's 14% of pilot flow. So pilot flow on a residential meter is 1/4 of a cubic foot per hour. So the amount of leakage downstream is 14% of pilot flow, or 0.035 cubic feet an hour. It's for this very reason, we do not market this device as a permanent disconnect device. It is built around safety. The meter is going to see an unsafe situation and shut the valve. Just to put it into perspective of, this leakage rate, if you had a room that was 10 feet by 10 feet by 10 feet and there was no ventilation, so that means no one's opening a door or opening or closing windows, it would actually take 52.5 days to reach a lower explosive limit based on this leakage rate downstream of the valve of 0.035 cubic feet an hour. But Itron is clearly marketing this as a safety shutoff valve, and it's not intended for permanent disconnect. So if we continue on to the next slide and just looking at some additional benefits, the far right corner, upper right corner, you can see that someone has dropped the gas meter from service and they've put in a bypass. Wow, someone touched the installation. Who's to say that that thing isn't leaking? Never mind the fact that they're stealing money from the utility, but that is a very unsafe situation. Well, the nice thing about the Intellis gas meter is it's looking at the speed of sound. So there's a different speed of sound for natural gas than there is for air. So we are able to detect that the composition, if you will, has changed from gas to air when they drop that meter from service, and we're going to send an alarm to the utility. Another thing is sometimes you'll see a homeowner who wants to cheat. They'll turn the meter in reverse. They'll they'll drop the meter from service, they'll turn it backwards, and they'll see the index going in a negative direction. The beauty of using Itron gas modules is that they always counted correctly. They count positive whether it's going in a reverse flow situation or not. But with the Intellis gas meter, if you're under a network, you'll actually get a reverse flow alarm. So having that air detection alarm and having a reverse flow alarm, you do need network for reverse flow, is additional benefits that also help safety as well as for theft. What you see in the background picture here is the shape of a diaphragm meter. That's a residential diaphragm meter that you can see in the shadow. In contrast, you can see the Itron Intellis meter in the forefront. So it's a 70% reduction in size. This meter now weighs 4.5 pounds, and there isn't a single utility that we show this meter to that doesn't just love this meter for its super compact and lightweight shape and design. We've heard utilities talk about worker injuries such as soft tissue. Handling heavy diaphragm meters results in worker compensation claims and that. So utilities are liking this lightweightness because it's a safer product for their employees to be using. As well, this compact size reduces the footprint, and it's less costly for warehousing and shipping. And the last comment I'll make on this slide is that the only time you're ever going to hear any noise from this meter is if the shutoff valve is working. So there's a motor-driven shutoff valve that's powered by the batteries in the index area. And the only time you're ever going to hear any noise whatsoever from this meter is if the valve is closing, or if the closing automatically, or if the utility sends a command to close it. And by the way, the utility does need to be present to open the valve back up. That's something that we listen to the gas utilities, and even though technically it would be you'd be able to allow the valve to open without the utility present. We've designed it such that the utility is present so that they can do all their safety leak tests before they restore service. So moving on, just a couple slides to wrap up here. This is an incident of, as I mentioned, we've shipped 75 million gas modules, and we've actually been doing this thing called data logging now since 2009. And this is an example, believe it or not, someone's broke into a home and stole a brand new furnace out of the home. You can see that this flow rate, there wasn't anything prior to 2 p.m. on October 29th of 2015. At around 2:20, all of a sudden you start seeing flow, and you're seeing actually 6 hours of wide open flow, which peaked at 600 cubic feet an hour. It looks like that fuel line would have been opened. In other words, the furnace would have been removed from the line at 2:20 in the afternoon. And then you can see how much flow rate went through the meter. And unfortunately, the house did explode. It wasn't the worst explosion we've seen, but the roof collapsed. It was a very bad explosion. So with the idea with Intelis is all this blue flow rate that you see, had someone broken into the home, stole the furnace at 2:20 in the afternoon, we would have had about 10 to 15 seconds worth of gas inside the home, which is not enough to cause an explosion. So it would have been, all this flow rate that you see would have not existed had there been an Intelis meter on this home. And that's the thing, we've been doing data logging, being able to look at the interval data on a gas meter now since 2009. And it was a natural fit for Itron to say, well, what can we do to prevent that explosion in the first place? And just the next slide just shows how bad it can be, an explosion. This incident occurred on April 15th of 2010. This was a 5,000 plus square foot home. And this is what was left of it. And we were able to look at the data logging data, and we were able to see, this was unbelievable. They had a wide open fuel line. It turns out it was the pool heater line that had been opened from the manifold, and wide flow going through this home for 7 hours. And it peaked at an unbelievable flow rate of 2,422 cubic feet an hour. So this, it would have been awesome had there been an Intelis gas meter, because this damaged 60 homes in the neighborhood. It's the worst one that Itron has been made aware of, over the years with us having data logging in the meter. It seemed like ever since we put data logging in the meter, all of a sudden my new part-time job was going out to the field and helping retrieve the flow rate through the meters before we had a tool that the utilities were able to use themselves. So we're all about what can we do to, make things safer. So just in conclusion there, a lot of benefits that Intelis brings to the market. From a revenue assurance standpoint at the bottom left, where we offer a more accurate meter. We also offer the air detection and reverse flow. From a distribution integrity standpoint, we have the ability to close the valve automatically at pre-programmable limits for flow rate as well as temperature. From a consumer safety standpoint, if someone mistakenly leaves a line open as they're changing out an appliance, the meter is going to detect that open fuel line and shut itself off. From a workforce protection standpoint, we offer temporary disconnect from a safe distance, so the utility employee doesn't have to walk right up to the house to be able to shut the gas off. And the other piece there is sometimes when the utility is going to turn off someone's service for non-payment, you hear stories of people pulling out guns on them. So it's much nicer, safer to be able to do that temporary disconnect from a safe distance. Also operational savings, because You're reducing injuries, again, soft tissue injuries, and less costs for shipping and warehousing, as well as customer satisfaction. I mean, this meter is definitely a step towards an aesthetically pleasing natural gas meter. So with that, I will hand it over to Brian, and we're done. We will open it up for questions.
Hey, Janet, this is Matt. I'm just going to step in quickly before
Sure.
we move over to Brian. Just a housekeeping item. I said use the Q&A function before for any questions. Let's go ahead and use the chat window, and we'll address any questions that come up at the end of Brian's presentation. Brian, over to you.
All right. Thank you, Matt. Can you hear me okay?
Yes, loud and clear. Thanks.
Great. All right. And thank you, Janet, as well, for that interesting presentation. So in this part of our presentation, we're going to talk about remote methane detection. My name is Brian Fute, and I'm Itron's gas marketing strategist. I've been with Itron for about 15 years, and I am based at their corporate headquarters in Liberty Lake, Washington, just outside of Spokane. Next. So at a high level, you can see the different components of our indoor methane detection solution. On the left is the new Cosmos ML310 methane detector with an Itron NIC or network interface card inside. That speaks over the Itron network and delivers the data to a methane sensing monitoring screen that you can see on the right. The way this works, it provides on-site leak monitoring for indoor and or vault type of locations. Important differentiation there. We are now looking at outdoor sensing technologies, but that'll use a different kind of sensing technology due to changes in atmospheric conditions, barometric pressure, wind, those kind of things. It will use more of a beam sensing. This uses a passive sensor where the methane plume will pass inside and be detected. The ML310 offers audio and visual local alerts, as well as the wireless alert through the Itron network connectivity. It's a very accurate device with very low false positives, and the users view the information through a geographic display, and it also has the capability to integrate into existing business processes at the utility, including the gas control center, the dispatch center, and potentially even live mobile use as the technicians respond to the gas alert. Before approaching or entering the building, they will be able to access this device, which is still taking readings when they arrive on site and prior to entering the facility. Next slide. Just worth mentioning here, don't want to pound our chests too hard, but we have been awarded, Itron has been awarded a Gold Stevie Award from the American Business Awards Group. This award recognizes innovative methane gas detectors developed with Con Edison and New Cosmos here in the US. Specifically, we were recognized for innovating the way utilities and cities manage energy and water, was named the winner of a Gold Stevie Award in the Industrial Products and Services category in the 18th Annual American Business Awards. The award recognizes Itron's nomination, Public Safety Innovation, Methane Gas Detectors. Next slide. So when we first set out to innovate and create this solution, these were the requirements. This is what we laid out as what we were going after. Specifically battery powered, that allows simple low-cost installation. Don't have to run AC cords inside of the utility customer's premise. We targeted 10% of LEL or lower explosive limit, as Janet had mentioned earlier, for methane only, and we'll do a refresher on that as well, just to make sure that's clear. We targeted 0 false positives, did not want to have any false alarms, as well as daily health checks for the device and the battery. We targeted 5 years of battery life, as well as specific certifications from UL and FCC, as well as our own. And we wanted to get that information in a timely manner. Within about 5 minutes was our product requirement. Next. So just as a refresher, if you're not already familiar with this, we didn't want to assume, but as it happens, natural gas is explosive within a specific range, basically 5% of volume to 17% of volume. Below that range, the density of methane, the ratio of methane to oxygen is insufficient for combustion and explosion. And once you get above that explosive range, it is again, it's too dense, it's too rich of a mixture, and it will not combust. And so that lower limit where it becomes explosive is referred to as the 100% of lower explosive limit level. Originally, we were targeting 25% LEL, and when we worked with this particular vendor, we were able to dial that down to actually 10% of the lower explosive limit in a very reliable and repeatable fashion. Next slide. So these are the kinds of pieces of data that are communicated by this sensor. First and foremost, of course, is the methane alarm. As I mentioned, there's audible and visual, persistent messages once it reaches the 10% LEL. And once it detects that presence of methane, it ramps up the reporting interval to every 30 seconds until the device is physically reset. So that alarm will stay active and alarm in real time or near real time from as low as 5% of LEL all the way up to 25%, with the assumption if it's at 25, it could be even higher, and that becomes a very dangerous situation that you need to know about. In addition to the alarming, the device also provides daily health checks. So it provides a heartbeat 3 times a day with device condition, battery situation, some runtime indicators. And if there are any failures or any end of life alarms, those are sent as well. And of course, all the messages include a timestamp derived through the network so that you know when this is happening. Next slide. So here are some of the things that you can do with this alarm if you're wanting to test it to make sure that it's working right or that you've got complete communication. You can ask it to send its alarm. You can simulate a 10% LEL with the audible visual as well as the network alarm. And again, that will stay in a persistent state until the device is reset. You can also cause it to send its health checks. You can send that 3 times daily, including the runtime indicator in hours. And you can also test the low battery alarm and the sensor operation failure alarm, as well as the end of life alarms. Next slide, please. So as mentioned previously, this is designed as an indoor alarm, and so obvious application would be in basements or meter rooms, service entry points, any kind of high consequence location, multi-dwelling units, hospitals, rest homes, those kind of things. And you want to get this up high in that particular room because methane is lighter than air, so it will rise. And so we're looking for mounting typically 6 to 12 inches from the ceiling. And a key component of that will be network connectivity. So as soon as that's installed, you'll know if it's seeing the network or not. If it's not seeing the network, you might have to relocate it to another place within the room. Next slide, please. How did Itron integrate this product? We use something that we refer to as our third-party partner ecosystem. And the way that this works is that Itron has designed a network interface card. It's that little chip up there on the right-hand side. And this is a device that any partner can integrate into their product, into their sensor. And so New Cosmos took this device and integrated it into their methane detector. But with the assistance of Itron and the third-party partner ecosystem, any partner out there, and there's a few others that we're working with down there. We've got Dresser and Eagle Research on the EVC side, Alexis with cathodic protection, and a few others. But any partner willing to work with Itron can take this NIC, integrate it into their product, and then the utility can purchase that product directly from the vendor. And it's got, kind of quote, Itron inside, and it's ready to hop on their Itron network as soon as it's installed. Next slide. So just a little bit of a closer look at the new Cosmos ML310, very trim device. As you can see, it's got the speaker on the upper right-hand corner of the front view, and it's got some LEDs. It's got a power LED, and there's the test button in the middle. The gas alarm indicated by a red LED, as well as the siren and the yellow LED for any kind of trouble issues. On the right side is the gas entry detection point, and on the back is the battery door. Next slide. So opening it up a little bit, you can see the key components. You can see the methane sensor, the actual sensing unit itself in the upper right-hand corner, and that's mounted on New Cosmos printed circuit board. And then on top of the New Cosmos PCB is our NIC, what we refer to as our 500M network interface card that New Cosmos has integrated directly into their product through the third-party partner ecosystem. And that's the piece that makes it a communicating device. That's what puts it on the Itron network and allows it to transmit those alarm messages in near real time. On the left-hand side, you can see where the lithium batteries are, as well as the speaker. And yes, next slide, please. Just a quick zoom in on the speaker, or I'm sorry, the sensor itself. We differentiate the words sensor and detector. The sensor shown here in this picture is the actual sensing device, the mechanism itself, hermetically sealed unit, metal oxide semiconductor. And the detector is the complete assembly. It's the device that detects and transmits the alarms when methane is present. Next slide. So we have partnered with Con Edison to deploy this technology. Their situation was basically that an operator was answering a call about a gas leak about every 8 minutes, and Con Edison's requirements are to respond to that leak within 30 minutes. And it was discovered that about 20% of the calls require some kind of repair. So in the case of Con Edison, as is the case with many other East Coast utilities, they have older systems, and they're beginning to show their age. So just some of the latest stats that we've moved on with. We've deployed more than this now, but at this time we had deployed about 9,000 of these methane detectors, and in that time frame we had detected 60 bona fide leaks that could very much have turned into tragic incidents and required repair. And in that time frame, there were 0 false positives. So again, a very accurate device and a very reliable device. It's not triggered by the usual things that can trigger a lot of different methane detectors on the market. The next slide, please. Just kind of wrapping up, as mentioned earlier, with Itron's vision of the third-party partner ecosystem, we're not stopping here, right? We are going to continue to evolve that ecosystem, continue to expand that envelope of capabilities to include remote pressure sensing and trending, end-of-line sensing, critical point sensing, low pressure sensing during outage. All of that is going to become a reality as part of this third-party partner ecosystem, and so it goes. We'll also be able to do inline and ambient temperature monitoring, remote BTU, or sometimes referred to as calorific or heat value, which we think will become extremely valuable as we start to introduce hydrogen and other renewables into the gas distribution system. There's going to be a need to be able to quickly and remotely measure the blend after the blend point. And a little bit further down the line, once the batteries are a little more refined, the in-pipe mercaptan density sensing is yet another of these capabilities that we're seeing envisioned as part of the ecosystem. And finally, then, to wrap up, next slide, please. And this is all part of Itron's vision of one platform for the industrial Internet of Things, powered by the Itron network and our software headend, that will create a network canopy of applications for smart utilities and smart cities going into the future. Next slide. And at this point, I would like to hand back to Matt for any Q&A. Thank you.
Great, thanks, Brian. Thank you, Janet. Great material. So as people go to the chat window to submit any Q&A. I just want to remind everyone that this presentation has been recorded, and we will send out the recording as well as a PDF of the slides post-event. And please, along with my contact information, so please feel free to reach out with any questions or comments once you receive that email. Brian, I wanted to touch on something that you mentioned about monitoring gas quality. And you mentioned as hydrogen and other renewables are mixed into traditional natural gas. Could you elaborate a little bit on that?
Sure, be glad to, because we do see this as yet another key issue facing pretty much all utilities in North America, around the world, the carbon neutral footprint, or the decarbonization. So, as mentioned, using the Itron 500M network interface card, what we're seeing is a lot of new technologies with the ability to detect the BTU value of gas through remote compact sensors. As most of you probably know, this is ordinarily requiring some kind of a laboratory environment with what's called a gas chromatograph, a rather large, delicate and expensive piece of laboratory test equipment, in order to detect the amount of methane in the overall natural gas mixture. What we're seeing now in the market is a variety of very small, like fit in the palm of your hand size devices that use a different kind of technology, what's called a correlative kind of technology. It uses other variables to correlate, specifically density, temperature, and flow. It can correlate to very high accuracy, plus or minus about 2%, the actual BTU value of the gas. And so for gas blend purposes, to ensure that we're hitting whatever BTU value that we're targeting at the blend points. And this will also probably become very important, not just to ensure that the blend is calibrated to the orifice size and the various appliances that we're serving off that distribution line, but what we also see is the opportunity also for more accurate billing for the consumer. Not only are we verifying that the blend point is correct, but we can put in beacon sensors, say one per neighborhood, and they can actually detect the BTU value of that gas as it's delivered to the customer, and that can become a more accurate part of the equation when that billing is created.
Great. Well, thanks a lot. It looks like we don't have any further questions, so I think that we can probably go ahead and conclude. I wanted to thank our presenters for taking time out of their day, but especially to those that have listened in. And again, please look in your inboxes for our follow-up email. We're going to be sending that out Monday. And again, my contact information will be on there if you have any further questions for our panelists or for myself. So thank you for joining us today. And with that, I think that we can go ahead and conclude. Have a great day.
Thanks, everyone. Stay safe.